Today we will be ending this course on a practical note in the sense that we will be having introduction to rapid prototyping, and for better understanding we also have a small yet fully functional rapid prototyping equipment which is widely used in the laboratories, in academics and research labs around the world in Europe and America. Uh, the rapid prototyping is very important in the sense that it forms a bridge between CAD and CAM. So after a product is designed, we know that unless and until we make its working prototype, we cannot come to know of its functionality, its strengths, its weaknesses, etc. So rapid prototyping has helped in reducing the development cycle of any product. So this session will be handled by Mr. Vinay Sharma. He was here yesterday. Yesterday also he gave a very important talk on the control systems, their modeling, simulation and implementation. So I'm sure that like yesterday, today his session will also be very fruitful, and for many of you probably you will be seeing a RPT in action for the first time. So please, this is a rare opportunity. Feel free to interact with Mr. Vinay Sharma, ask questions, clarify your doubts and make full use of this session. So I invite Mr. Vinay Sharma.
Thank you, sir. Good morning, all, and thanks for inviting me once again to show one of our product, which is a 3D printer. But I would be focusing more on how to use this product for your development of your applications and how you can make the best use of it for welfare of your students. So this 3D printer or 3D printing, or I should say also known as rapid prototyping, is a very age-old technique which has been used by engineers to prototype any developing model. For example, you must have seen lots of old projects in your mechanical department or maybe CAD department where students make use of wood to fabricate and prototype model before going for an actual prototype. The die makers, they have been using such kind of wooden model from a long time to present and final draft before the customer so that they can have a look and feel of the model, and before implementing the final metallic version or actual designing the die, they can decide if there any changes are required or not. So rapid prototyping is a known technique, but with the advent of technology and some tools available, this is now much more easier to implement as compared with the age-old techniques of wood or other things used earlier. So as you can see, so if you surf through the internet, you will find that the 3D printing or rapid prototyping technology is being creating a lots of news. There have been lots of websites or lots of development which is happening in this technology, because with the advent of newly developed printers, this technology has reached to each laboratories or colleges or even the household or to the craft and hobby makers to use it for their exploring their ideas and implementing into the real world. Okay. So if you look around the market, who are these people who are using the 3D printing or the rapid prototyping technology? The mostly used domain or the industries are automobile sector. Now why is that? Because automobile developers, they design a prototype of the car or a vehicle to make sure that the component which they are designing, it is going to fit properly in the vehicle. So that may be even simply your steering wheel, it may be the dashboard, or it may be just the lever, or it may be just your gear changer handle. So there are variety of components which are available in your car or vehicle, which has to be prototyped first before, you know, designing the final draft. Because if I'm designing a steering wheel which is of a different size, so I need to put it in the hands of the user and ask him that how does it feels for gripping that size, and how does it having, like, is the steering wheel is big or small enough, or they need to improvise something. So that is why the automobile industries are using to the maximum this technology. Later on, there are lots of consumer products, as you can understand now, that if you are designing a bottle or a jar, or even let's say the laptop, or even let's say the projector, if you want to make a model of it, that is every company is going to fit inside the box in the proper shape or format or not. So for that purpose, consumer market and the business machines, even the medical, and now the academic institutes are also using the 3D printing technology for as a facility to be provided to the students, so that they can implement their ideas using this technology and learn better. So let's define what exactly we mean by rapid prototyping or 3D prototyping. So it is a kind of technique in which either additive or subtractive method is used, but I would be focusing on the additive technology. So where it's a process for making a 3D shape eventually layer in the layer by layer format. So where you put a material in a box or at the platform, and layer by layer you add the material so that it will take a proper shape of a 3D geometry. Okay. I should probably indulge more information on that how exactly this thing happens, how an 3D printing shape or 3D printer can give a shape to a 3D geometry. So let's take an example of this. There is a platform you have. Okay. So in the PPT, you can see that there is a platform, and there would be a nozzle, which is also called as an extruder. So this, if I call as an extruder, so this would be depositing a molten plastic or the molten material, and he will be depositing on the platform in a layer by layer format. And as the material comes out in the contact of air, it solidifies, and it solidifies at the enough level of liquid state so that at least it will be sticked on top of each other. You can take lots of examples. This morning some gentlemen were discussing, and just like the same of making a jalebi, but jalebi is in a 2D format. But if you can erect a jalebi in a layer by layer structure, then definitely it will be a 3D geometry. Only the difference is that the jalebi maker is controlling through his hand and the creativity of his mind, whereas there in the printers, this technique is being taken care of by the softwares. So they decide what should be the movement or the axis movement of the extruder, and how the shape has to be given. So I would be focusing on this technology, which is also known as fuse deposition molding. Okay, where you just fuse or melt down a plastic and you mold it on layer by layer structure on the platform. The other very popular technologies which are available are selective laser sintering, SLS, or DLP, and there are a couple of more technologies available. The difference between the technology which I would be focusing and others are that in this case they melt the plastic, whereas in case of DLP, digital light projection, the plastic is already available in the molten state. So that means they pour a layer of liquid and they cure the liquid shape depending on using a light technology. So either using a laser or using a very narrow beam of a light, and they cure the plastic. So as the plastic comes into the exposure of light, it solidifies, and layer by layer you construct the 3D geometry. So the prototyping industries are huge. There are lots of engineering, industrial architectures, die makers, or automobile people, or even in the education or robotic people. They can make use of this technology to implement their ideas and use it for some innovative purpose. Now, what kind of purpose I should be using for a 3D printer? So the purpose are, you want to just prove a concept. That, for example, there is a shock absorber, and photograph has been shown that I want to construct some different kind of shock absorber. So how does it look like? How it is going to functionally will fit into the body of the design? So I want to use it for that purpose, or in fact you just want to use it for functional testing. There is just a belt buckle design, so there is a different method you want to make use of it, and you want to just test that the functionally they are going to fit properly into each other. For that purpose you can use the 3D printers, or just for the product mockups, just for presentation to the customers, or you can even use it for as a marketing tools. You can make some toys or gift articles for your customers. You can use it for engineering purpose or educating students any concepts, okay? Or even some people are also using for medical studies. So these are the applications for where people are making use of 3D printers for their deploying ideas. So today I have this printer with me. So as you can see, there is a printer which is named as Fabster. So this printer is from a German company, and I brought this printer here just to show you how exactly 3D printer make use, and how you can make use of this printer to create some product. So I just first explain this product, what are the features and how does this function. Laterwards we will see that how you can print any geometry using this printer. So this printer can print any 3D geometry out of using a plastic material. Okay, I just explained the technical specs of this printer first. So what are the general technical specs of a printer? So these are the specs of the printer, this Fabster, but let me explain in a generic format. Okay, so basically the first thing which you should highlight out is what are the printing dimensions. So as you can see, the maximum build volume of this printer is around 230 by 230 by 210 millimeter, or let's say I make it a round value, then around 200 millimeters of cubic object he can print into this platform. So size of the printing volume matters a lot. The bigger the printing volume, that means you can print in a bigger size. If the volume is smaller, then probably you have to print in multiple parts and stick the parts together. Laterwards, you can see the traveling speed, or the speed of this. So you can see this traveling speed or the printing speed of this printer is around 300 millimeters per second. So that is one of the fastest printers available. Okay, because this guy works at 24 volt DC, and that too at a micro stepping mode using the stepper motors. Then the most important thing is that what kind of layer thickness accuracy it can offer. Because when, as we discussed earlier, that the printing happens layer by layer. So what is the thickness of the layer which is being used to construct the object? The thinner the layer would be, the more accurate or more precise shape of the geometry will come out, and you will have better surface smoothness, and also surface precision would be better. So this guy can print till level around 44 to 88 microns, which is a very high accuracy as the given technology available. So let me explain the construction of this printer. So this is the platform, which is also called as build platform, on which the object is being constructed. On top of it you can see there is an extruder, and from here the plastic comes out and deposits on the platform. You can see a pipe coming through it. So from this pipe the plastic is being fed to the extruder. So the plastic is coming from an cartridge, from where the plastic has been stacked together, and one by one the sticks comes out and goes to the extruder. On the left hand side you see a box, so that is an electronic controller. So there is a microprocessor and who's controlling the movement of the motors, and he takes care for the communication with the software which is in your PC or the laptop. You can see that there are steel frames and there are some cassettes have been used to construct the body of the printer. So you can see these are the cassettes which binds the printer body using the rods. So these cassettes are uniquely designed and patented, because that is one of the very unique, because the printer comes in and total disassembled as an accessory. So the user has to assemble the entire printer. So these cassettes make it very comfortable and easier to assemble the printer. Now let me tell you about the material which is available. The material which is being fed to this printer are the plastic sticks. Okay, and they made this plastic sticks using a shape given by a cogging kind of shape. Now with this cogging, understand that when there is a round filament, so that means someone has to push the material inside the printer. So if the material is being pushed down, and if I have a circular shape, so that means the rollers have to push it down. Now the contact point between the roller and this round body is very minimal. So that means if I have to push it down at very faster speed and pull it back upwards, so that may cause some kind of slips, because if I'm pushing it very fast up and down, so the plastic may slip, the rollers may slip due to wear and tear. So that will not give a precise dose to your printer, and eventually the layer formation would be not proper. But whereas in this case, you can see there are some gears mechanisms are being used to push the material up and down. Probably at this point of time I should show you a video where you can understand how exactly this printer makes use of sticks. So here you can see the printer is busy in printing some object. So on the right hand side you can see the cartridge from where the plastic is being fed to the printer. So here you can see the object is being taking shape. Now remember, this 3D printing technology itself is a slow technology, means you cannot expect that the object is just finished in a couple of minutes. No, it takes some hours to print a job. Yeah, because this happens slowly, it's a slow process. So you have to be patient enough to get your part printed. So here you can see some kind of helmet is being printed. Yeah. So such kind of structures can be printed. And so let me show you in one other video. There you can see there is some object which is named as a pirate coin, which has been printed. So you can see in the software they are looking at the object, and the user just generates a toolpath which is a kind of G code only, and exports to the printer. So it takes around 40 minutes to print this coin. Sorry, looks like video is after broken. So I take some another video. Yeah. So there you can see the user is feeding the sticks in the cartridge.
You simply have to attach the magazine to the printer.
The cartridge is loaded on the side of the printer. So there are a couple of places where you can install the cartridge, either on the right hand side or on the left of the printer. So there you can see there is a gear system through which the material comes out.
Like stick hookup system is simple, but smooth and efficient. This joining takes place automatically while the
I would
sticks
be
are
showing that.
extracted from the magazine. The ingenious stick system allows you to combine different colors from all the colored parts.
You can mix the colors also. So here you can see the material goes inside. So there is the extruder. So you see this is an extruder which is a metal body. So you see some white wires which are being coiled around this extruder. So these are the heating coils. So it heats up that metal body, and when the plastic goes inside this metal body, it just liquefies, and when it is pressed on the top force, so it comes out in just a form of a thin wire. So that is being deposited layer by layer on the platform, and that gives a shape to the object. So there you can see it feeds using the gear system, so that gives more precise dose to the object.
Supply and back of the extruder with its brilliant feedback.
And this printer make use of sticks. So you can see as the sticks comes out of the cartridge, it pulls the another sticks into it.
Faster, easy 3D printing for everybody. Join the revolution.
Okay. And there are a variety of colors available, so it's not necessary you have to paint the object. If you want, you can paint it, that is allowed. You can use some oil paint or water-based paints to give a color, but otherwise there are around 10 to 12 colors available in the sticks, so you can print according to your colors required. Yes, this plastic is ABS. Okay, there are other plastic materials I would be explaining about. Other plastic which are available are PLA, polylactic acid, and flexible material, and wood-like finish. So these are the cassettes which are used to construct the printer. So these are patented one. So you can see there are very simple cassettes to use, and all the mechanism is being built around using the same cassette only. So this is the extruder. So as you have seen in the video, the plastic comes out from the top of the extruder. There is a gear mechanism at the back which pushes the plastic inside this metal extruder, and it liquefies and comes out of the extruder and deposits on the object. So shall I show you some printing? That I'll just show you how does the plastic comes out from this extruder. So for that I have to turn on the machine. I just start my software. So from the software, I just connect with this printer. So here I can ask this printer to increase the temperature of this extruder to around 250 degree. So you can see the temperature will rise of the extruder. There is a feedback. In the meanwhile, I just bring the extruder in the center. So here we can see the temperature has rose to around 150-60. Now the material which I am using as of now is an ABS, so which is a very commonly used plastic material, and generally your toys or household items are also being made up using the same ABS plastic. So the melting point of this plastic is around 220 degrees centigrade and onwards. 230 to around 250 degree, it melts down. So as my temperature has rose to that level, I just increase the speed of my extruder. This is I'm doing manually just to demonstrate how the plastic comes out. So here we can zoom in, and here we can see that plastic is coming out from the extruder in the form of wire. Now, if the software is controlling the movement of the extruder, then automatically it will give a shape to the object. Yeah. So there you can see plastic is coming from the extruder. So the user has to make sure that he doesn't touch the extruder because it is very hot. You might burn off your fingers if you do that. Okay. So you can see it's very thin wire. It's a very thin wire, as you can see in the background of my hand. It's just slightly thicker than your hairs, not mine, only yours. Okay. So I just stop this. Okay. Yes, as you can see, it comes into the contact of air. I just start again. See, when it comes into the contact of air, there is an abrupt change in temperature. Remember that this has been melting at the 250 degrees centigrade. So as it comes down to a room temperature, it solidifies. So you can see it's solid enough. Although this is a hair thin, so that means it will break up if you apply force. This is solid enough. So that is why this plastic material is being used. As you can understand that whenever you make a mehendi design, so it is the same technique. You're also dropping the material, but then the mehendi takes few hours to solidify. But here it takes only few microseconds or few milliseconds to solidify. Okay. So we come back to the presentation.
While making
Yeah.
while making any component of prototype, this entire system is enclosed with some.
No, this is kept in an open enclosure, but if you wish, you can put it in an enclosure also. Using some acrylic sheets, you can create some enclosure. Generally, it is recommended that yes, whenever you keep it, you can keep it as good as you like. But ABS has a property that it shrinks very fast. So if the room is too much cold, so then there would be abrupt change in temperature, and probably the solidification will not happen in a proper shape or format. Thank you. Okay. So for that purpose, I explained this concept in the presentation, that is heated bed. Now, when the object comes on the platform, as I'm using the material ABS, the ABS is a property that is, it has some elasticity components. So that means when it solidifies, it shrinks. It creates some tension across its points. So because of that, the material may warp. Warping is a process when the solid, the shape of the plastic may change because of the elasticity of the plastic. So if you're printing some object, so it might not be flat across the corner. For example, I'm printing some block. So from the corner, it may start lifting because there is a tension across the points. So from both the ends, the plastic may start lifting up. So that is called as warping. Now this is because when it comes out from the extruder, this is at 200 degrees and it comes to the room temperature, there is an abrupt change. And if there is room is too much of AC or cold environment is there, the warping will happen more. So to avoid that, the printer comes along with a heated bed. So what you see this platform, this is having a heating coil at the on the bottom side. So from the downside also it is heating up so that the plastic material do not cools down so fast. So that is why the printer comes with a heated bed, and you can see in the presentation it can heat up around to 140 degrees centigrade. Okay. The software which is used to control this printer is from the same company. They have a sister concern and they have made a product named as NetFab, and this is one of the very professional software available for this additive manufacturing technology. and lots of professional printer makers are also using this software for improvise their 3D printing. I will be showing the features of the software when I make use of it. So there are lots of editing and processing on the object you can do when you import the CAD files, because it's very obvious that how do I get the 3D geometry? You have to get it from some 3D CAD software like AutoCAD, CATIA, or ProE, or maybe SolidWorks. From these software you can get your CAD model and you can process and print the model from here. The materials available in this printer are, there's ABS, which I've already shown to you. The other ones available are flexible material. There is a PLA and also wood-like finish, which is coming up next. Now the PLA is a polylactic acid gel, like biodegradable and environment friendly material, but it has a property that it gives a more smoother finish and it's a glossy in nature. There is a better shine, it looks better in look and feel. Whereas this flexible material, this has a property that once constructed, it can retain its elasticity property, and you can press, squeeze, or you can change shape. So for lots of application where you want to print, let's say tire or something like that kind of structure, or shock absorbers, you can make use of this. So I'll just show one video which will explain the flexible material. So you can see there are two identical objects which looks like some vase in the side by side. So by look and feel and visibility parameter, they look almost the same. The user is hitting using the hammer, but still you can see the object survives the test and does not break. Now he takes the same ABS material, so if you press hard, it will break up. This guy is brittle. So flexible material you can make use of for variety of application. Only your imaginations are the limits. Abrodyne, butadiene, styrene. I mean, it's a very jargony name. Okay. Okay. So let me show you some printing techniques. Now this is the software NetFab engine, which is being used to communicate with this printer and also process your models. Generally the software which are available to control printers, they only offer you to just connect with the printer and print. They do not allow you some kind of processing. Whereas this software will allow you some kind of processing. You can also do using the some features available. So let's say you want to generate some primitive components. So there is a part library. So you can generate some primitive components like boxes, pyramid, some cylinders. Okay. So let's say I want to print a cylinder. Okay. So I have a geometry of the cylinder. So I can specify how much is the height I want. Let's say only 10 millimeter I want. What is the radius? Okay. So let's say again 10 is the radius. Now this is the tolerance he will ask for, because here you can see that okay, he has generated the geometry, but you can see that the triangles are not that smooth enough. Okay, so you can increase the tolerance to give a proper shape. Still it is some jaggery on the sides. So I increase my tolerance to 0.01. So now this guys get some better shape of the cylinder. You can make it hollow, shell, or the solid type. So I ask him to make a shell. Now as the radius as specified was 10 millimeters, so obviously the dia is 20. So if the wall thickness is 10, so that means from here center to outside is 10. So that means it is not that shell. So I specify the thickness as around 2 millimeter there. So this shell now looks good enough. So I can say, okay, create this part. I reduce the height to 5 so that we can print faster. 5, okay. Now, so here is your part, which is being generated by the software. If you can see the length, width, and the height over here. If you still want to make some changes, you can scale the part. So I right click and say scale geometry. If I do not want the fixed scaling ratio, I can remove this flag and I ask the software to make the Z, which is height, instead of 10 as 5. So now this just represents a small ring. Okay, so let's say I want to print this. Okay, so I just drag this component and bring it to the printer domain. There you can see in the corner of the platform. So it shows the platform of the same build volume, and on the corner there is the ring over there. So I ask him to bring it into the center and I zoom it to it. So there is my ring over there. So let's say now I want to start the print process. Now for the print process, I have to specify the printer, that what kind of material I'm using. So here you can see that the configuration is set to ABS. So if I go to the style tab, I have to select which material I'm using. So you can see there are lots of material available, like flexible is there, high temperature, and the PLA is also, okay, it's not in this laptop. So I just select the ABS. If I want to change the layer height, so if you remember I discussed that, okay, the layer height I can change it. So I go to manage material and ask him to change the layer height. So here you can see the layer height is set to around 0.2 mm. So that is 200 microns. So I can come down to 100 microns also. So let me first print at 200 microns. Then we will change. Okay. Now I just select the print quality. So there are lots of print quality available. So if I start with the rough one, so you see there is a rough print quality, and I'll ask him to calculate the tool path. So here the software will tell me that I will just take 1 minute to print this cylinder. Now it depends what is the amount of print time you want to invest in testing this print. So in this case, he will print very fast, but the quality of the print would not be that good. But if you select the standard quality and ask him to calculate tool path, so he will take around 2 minutes to print, but it will be of a better shape and a better quality. In the same fashion, if I select a fine print quality, so he will take more time, but he will give a much smoother shape to this. So you can see the number of layers have increased of this cylinder, and he will take around 4 minutes to print. So let me select first standard so that we can compare the both qualities. So he takes around 2.5 minutes. Okay. Now before printing, I have to bring the printer to the home position. So I just turn off the printer and I bring this extruder to its home position, which is on to your top first left corner. Okay. So that comes to the home position. I just turn on again. And I just say, okay, print. In the software, I just click one button, print. So here you can see the temperature will rise of the extruder to the set temperature which are used for extruding. And once the temperature reaches to the desired level, then only it will start printing, not before than that.
Temperature again is 250.
Yes, 250 not 230, because the melting starts by 220. So the first level it reaches 230, then starts print. So in the software, it shows the tool path animation, that how it's printing, and on the printer also you can see it prints the same geometry. So the first what you see is the blue shape on the bottom side. He's creating a raft. He creates a platform which on which it's a kind of support material on which the object would be printed. Yes. So there you can see it is animating and also printing at the same time. So there you can see the first two layers have been created.
वैक्यूम जर्नी का अपने स्टैटिक लेने का
वैक्यूम नहीं है,
स्टिक कैसे कलेक्ट कर रहे हो
स्टिक एक बार वन बाय वन पुल कर रहा है, इट्स पुलिंग वन बाय वन,
मैं गियर मैकेनिज्म
नॉट gear mechanism actually. I'll remove the link. So there you can see on the extruder, I mean this cartridge, so there is a stick over here. So as it comes out very slowly, and you see it pulls another stick. So you can see that the joint it makes. So it pulls out slowly. So when it comes to the corner, the above stick will drop down and will lock automatically.
how it is drawing sir how it comes under this stick
Right, because the tube is being fed to here.
yeah
The tube is connected here.
what is the pulling power sir how it
No,
is
because there is a motor at the back of the extruder pushing it down. It's pulling it. If you want, you can come closer and have a look. How does it feel, friends? So this material will slowly will go down and will be consumed. If required, we can change colors. Yes, the software will give you an estimation that how much amount of material would be required. These sticks which are there, I'll just show you over there itself. So this one stick is around of 2 grams. So he will give you an estimate for that.
Because we have given message, so only one step is wrong. Because it is not sufficient and
Yes, obviously. So if the material is finished, or there is a sensor inside who will stop printing when if the material is absent over there. So you can just pause, you can put the stick inside and start printing again. So there you can see that the printing has finished. So I just use a scalpel to remove this printed part. Yes, so this is bottom side is the raft, okay, and on top of it there is cylinder. So I just gently remove this. The removing is easier. It sticks to the platform. So I just remove this raft from the bottom side. So it just take a little efforts to remove the raft from the bottom. Yeah.
this thing sir if you keep this printer somewhere some foreign places and instruction you can leave from here
Yes, if you can connect to your computer, then you can start printing.
it's not like a Wi-Fi like it's mobile sitting
No.
in some other city
They are planning
With
for a
this-
network connected printing
network, yeah.
facility, so that can be done.
that can-
But it's always good someone is standing with the printer. And
so it is
observing.
just like a transferring the mass like अब जैसे हम सोचते हैं कि यार कि वेव्स को ट्रांसफर हम कर सकते हैं या एक जगह दूसरी जगह
जी
बट मास वाज नॉट, 1 लाख वही हो गया 1 लाख नहीं, हम प्रिंटर हम अमेरिका में लेके बैठे हैं, इंस्ट्रक्शन हम यहाँ पे दे रहे हैं, तो इट विल वर्क।
या दिस विल वर्क डेफिनेटली, नेटवर्क प्रिंटिंग आप कर सकते हैं, but it's always good that someone is standing by with the printer and watching the progress. Okay. So let's take some more example and let's keep it back. आप फुल करके देखिए, आप कर जाएगा।
सर ये ऑन करना पड़ेगा
जी,
इसको ऑन करना पड़ेगा, सेलेक्ट नहीं कर रहा ना सेकंड वाला।
नहीं इसको धीरे धीरे वो आप बहुत तेज पर निकल जाएगा, ठीक है। ये आप बिकॉज वो जो पुल करता है बहुत धीरे धीरे करता है, इट्स वेरी स्लो, इससे भी स्लो है, बहुत स्लो, एकदम धीरे धीरे आता है, देखो नीचे से घिरा धीरे से,
लॉकिंग सिस्टम है।
so there is a locking system between the sticks.
स्पीड है ये
It comes very slowly, it comes very slowly out, you know, at very slow speed, you know, 1 millimeter,
ਉਹਨਾਂ ਦੇ ਜਿਹੜਾ ਵਾਈਬ੍ਰੇਟ ਉਹ ਨੀਚੇ ਆ ਜਾਂਦੀ
you
ਹੈ।
know, it comes down and locks and it comes down.
तो फर्स्ट टाइम मुझे कोई मतलब फिल करोगे आप इसमें?
Yes, आप एक और प्रिंट देते हैं,
नहीं फर्स्ट टाइम अगर फिल ऐसा
आपको फिल करना पड़ता है,
हाँ।
या तो फिल अप। तो अभी मैं एक कलर चेंज करके देखता हूँ, मैं ये अभी पिंक कलर लेता हूँ एंड आई जस्ट फिल अप फ्रॉम द फर्स्ट साइड।
सर मिक्स्ड कलर नहीं है।
मिक्स कलर कर सकते हैं, तो नेक्स्ट पार्ट वी प्रिंट यूजिंग मिक्स कलर्स।
पेपर बन जाएगा
तर रीड ना बनना
अच्छा हीटर
कहाँ पे? नीचे
हाँ नीचे
नीचे नीचे का।
8 विजन का 24 वोल्ट
जी
पेटर 24 वोल्ट
हाँ 24 वोल्ट। So I connect back the cable so that we can resume printing.
What it goes, sir? This one.
It's as I said yesterday, the commercials have been asked not to talk in front of cameras at least.
It is in lakhs or crores.
In lakhs.
Near about.
Let's say DLP, a professional DLP printer starts from around 25 lakhs. The laser sintering machine starts around 50 lakhs. So now you can estimate how much this would be. And I would say that it is around 1/10, less than 1/10 the price of these. Now you make the mathematics. Okay. So let's come back to the software and take some readily available file instead of generating a part from the software. So there are lots of CAD files available from where you can print the objects. Now you can see there is an STL, he can import various kind of STL file also. Now you can see if I open a file, so here you can see a huge list of files which the software can import, right from STL, 3ds, binary files, okay, or the slice files he can directly import and give it to the print. So as of now I have lots of STL files which I will first show you that what kind of parts the people print. So here you can see this is a functional model of a belt clip. So that is the fork and that is a sleeve which you can print using this printer. Then there was a functional model. Yeah. So this is a turbine model. So here you can see blade fins for this model. So you can see these fins are very thin, but still this can be printable using this printer.
We'll go for this.
You want to print this? It will take an hour or something. That's why.
But if you decrease the size, and
We can decrease the size, but then see. Okay, I tell you some part which are not directly related. Yeah. Now, if I look from the top view, now you see there is a this is the fin thickness. Okay. I ask him to measure this. Now this measuring tool is also available in the software. So I just zoom up. So that is a fin thickness. I ask him to measure this. So approximately it should be around 0.5 mm, or let's say around close to 0.6 mm. This would be from here around here. So around 0.6 mm is the thickness. Now if you remember in my presentation, I've shown you that the minimum wall thickness it can print is around 0.6. See, there is a minimum amount of thickness also of a part it can print, because it prints one line then another line. So this was minimum 0.6. Now if I scale this guy to let's say 50%, so this wall thickness will become 0.3. So then this won't be printable then. Printing nahi ho payegi. Otherwise I would be glad. Shall I otherwise slice it then print? Is that okay to you? Okay, let's try first that how much amount of time it takes. So let's say this is my design and I want to print this part. So I just drag and drop to the software and bring it to the center. Now you can see this guy is vertically standing, but if I print like this, there would be some problems. Now what kind of problems? One, that this is hanging. These parts are hanging from the platform. So that means I have to provide some kind of support to this. Now adding a support material, that will take extra time and efforts and also material. So instead of that, if I can flatten it out, so I can rotate this guy. I just right click and I say rotate to the x-axis by 90 degrees. Sorry, y-axis. Yeah. So 180 degree. Yeah. So you can rotate the part and bring it to a flat level. Okay. So now let's say I say okay, use the same standard part. Okay, standard quality, and instead of solid, now you see on the last in the software it offers a feature that how much of the fill spacing you want. If a part is entirely solid, okay, and you don't want to print in a solid form, so you can tell the software that okay, don't fill solid, but fill it by a distance of let's say 2.5 mm. So we will create some hatching structure, honeycomb structures. So the software take couples of minutes to find the tool path. So depending on the time, we will decide that it is possible in the given time frame to print. Yeah, otherwise I will open something simple to print. So it will take around 40 minutes to print this part, and this is just an estimate. You may even overshoot by 10-15 minutes. So this would be difficult to print. So what shall I do? I do one thing, I cut this part. I just slice this, cut this part, and let's try to print. Yeah, sure. Now most of the software, they do not offer you editing features, but this software has editing features. So I just see a top view. So in the Z, I slice by execute this cut. So,
We can go for 1/4 also.
yeah, so there is, you can see this part is being cut around. Okay, and I tell the software, okay, I want one more part of this. Okay, I take this fin and leave this fin. Okay, there is some hanging fin, but we will ignore that part. So there are around 2-3 fins are there in that part. So this we can try at least. Yeah. So I bring it to the center. I rotate this guy. So here, so there is my part I want to print. So there you can see that there is some hanging of this part over here on this corner, but I won't be providing some support. Or if I want, I can even provide that. Yes, I can do that. There is an option to provide some support material. So if I ask him to fluff support and calculate the tool path, so He takes around 17 minutes. But you see there are lots of support material he generates. So the blue color which you see is the support material he constructs. Now I do not want that amount of support because I'm confident enough that this irregular shape can be printed without support. But I believe that support is required only at this corner, not any other place. So I can ask the software that to provide a customized support for me. So I select an easy support and use some constructive support material over here. There. So only a support material on this corner would be used. So I can make some massive wall. Yeah, that should be good. So only a support here would be generated. Now when I generate the tool path, so let us see how much time it takes. Yeah, it will take around 12 minutes to print. I believe we can go for this. We can even go for entirely hollow. Let me see how much time optimization is happening. Not much. It will still take 11 minutes to print and around 1 gram. So I will not go for entirely hollow. I will take around 2.5 mm of the filling. So there you can see it will print layer by layer. So here you can see the layer structure one by one. So here you see these are the empty spaces, but he's only printing lines in between. So these are nothing but the fill spacing. Yeah. So here I just bring this printer to its initial position. And in the software, I just tell the software to print the job, and it will upload the data to the machine. Once the printing starts, you can even remove the computer and turn it off, because he will keep his data stored in the SD card and will print it from there. You can even, if the machine and printer are then they are not close to each other, you can even generate the print job over there, copy to the SD card, load it to the machine and print directly. So it is not necessary that printer and the laptop or your computer should be side by side.
By the time it finishes this work, you can plan for another.
Yes, I can just open another software, GUI, and I just show you some more models to it for your reference. That what kind of printing people do it. In the meantime, it will just heat up and print. So I just open the software and show you some models. Some creative models of some creatures or faces of the people, even that is the face of the US President, Mr. Obama, and someone has made this such a beautiful model, but along with the support material at its chin also, which can be removed after its prints. So that's a good model to print for the faces of people that can be also printed. That's a human head, which can be used for printing purpose or reference purpose.
For that, printing a human face, you need photographs and all something. How you specify that?
Someone has made this model actually. Yes, someone has created from an image a picture.
Dimensions and all for a face. For other vertical materials, we can use dimensions.
Yes.
For these things,
See, someone has made it because there are some softwares available which are used for scanning purpose, or even from the images you can convert to 3D model. So you see, this is a coupling design, a flexible coupling, and some gears are also available. Such kind of gears you can make up. Okay.
size.
You can open this file and see the size, because this is just, I'm looking was a preview. I just opened up. So the length and width is around, the dia is around 80. The dia of this is around 80 mm. So just have a look. So you see, this is a shape of a differential gear assembly, which can be used for educating students that how the differential gear works. Someone has made this assembly. This is not made by me. So in the meanwhile, if you have any questions, you can ask. Any questions you have? Yes. Right. Yes. So it will be also printed using same ABS material. No, then the support material has to be removed. So you have to identify that this is support material, and that is very fragile actually. No, the support and material you cannot differentiate in colors. They will come in the same print material, same print color, similar as that. Yeah. So you have to see, this technology itself has one drawback. I won't say a drawback, but a kind of limitation, that it requires a post processing. Because once the part has been printed, you have to file, sanding process has to be done if it is the printing has been not up to your mark. But then the cost what you are involved is also very minimal as compared to professional printers. The professional printers which are available, they are very big in size. They are so big in size that you have to dedicate a separate room for that. They are almost in the size of a small car. So that means you have to dedicate a separate room. They require a huge amount of power supply, and the cost extra involved for printing also is huge. Whereas this guy is very small. You can put, as you can see, I carried this morning in a car, yeah, and I brought it here without any damage. It starts printing, and it's printing fine also. And a little bit of post processing required, but then the cost involved are very less. And the processing is very simple because that's a plastic. So you can print multiple parts, you can glue them together, you can do sanding, filing. Yes, the organs etc. can also be printed, and I just check if I have any videos or pictures. Sure. Yes, there are lots of people who are medical in using for medical research also. Even the limbs etc. they are printing with this joints. I just get my mobile. I have some couple of pictures for you to show. There you can see that's a complete human head is printed using the same printer, and you can see the size also. It's quite a big. So that's an. We did this prototyping work for a customer. I mean, our engineer was as at his place to print this job, and I'll show you some more. I'll just open just a second. I just open one more quickly. So this is another part printed using the same printer. So that's a human skull, and that's a very small one. You can see it is in my hand only. It's in my palms. So that's very small skull printed. I'll show you one more uh, video and some part. Yeah. So here you can see that I'm standing with an scaled model of a robot which is made by some military organization, and we made the scaled model which was you can compare with my standing in by side. That was a big size. So this was 0.3 scale of the original version, but it took 1 week to print this job. I just show you a video so that you get an idea of its function working. Yeah. So there you can see the multiple joints were connected using bolt and screws, and it was functioning as per the original version, but not with robots and motors and encoders etc. But yeah, it worked fine. You can see the part printed. I'm just little worried on the room temperature because of the wind flow, and if the cool air is touching the part, then the warping may occur in the part printer. So it's always recommended that the room temperature should not be that cold enough. Okay. Any other questions if you have?
So then if we invest in the fabrics or helpful in modeling robotics,
How do you?
how do you go about printing this like how do we printing this?
So as you can see that, that was a big job which was printed. Then you make sure that you are not turning it on AC. You have to little bit spare on your comfort. Because many people complain that the warping is happening too much. Then we found that there were two ACs running in the laboratory and the temperature was around 18 degrees. So if that is so much cold, so the warping will affect more. Otherwise the parts print very good enough. You can see that human skull, human face which was printed, that was around almost 8 inch in height, and it around 60 hours to print that job. So let me check it is on which layer. So here we can see that yes, it has printed around 5 millimeters in height. So there you can see that I have changed the color. Instead of red one, I have fed pink sticks, so that now you can see the change in color happening in the part. Anyone else has questions from the remote centers? If someone has questions from remote centers, please, from Jaipur, Ghaziabad.
Hello.
Yes, ma'am.
Sir, from ABS College. Sir, I would like to know what is the material of the platform.
The platform use an aluminum plate coated with an orange layer of a thin plastic, which is a kind of polypropylene. It's a kind of PP material, but it is just to make sure that the ABS material which comes out sticks properly on the platform. But you see this yellow color in the screen on the platform, that is actually a melted layer of ABS we have applied, so that the sticking is better.
Okay, sir. And what about the heater that you said? Like you heated the platform to like about 40 degrees Celsius. So where is the heater embedded?
See, it is heated so that the warping is less, because when the platform is heated, so that when the material comes out, it do not cools down faster. So it will cool down slowly.
Okay, so like the heater is embedded below the surface.
Yes, it is embedded below the surface, below the aluminum plate.
इसे भी देख लो कुछ बना रहा है
Okay. Now there was a fin which was hanging in the air. We forgot about this one fin. So probably it would have required a better support on that. Yeah.
It's giving slowed or what?
No, that was broken, so that is okay. One fin has been broken, but other fins are coming okay, at least in the standard quality. Actually, this part requires fine quality and a lower layer thickness. It is just to save time, I have printed this job on this fastest possible method. So as you can see, the estimate he has given was around 12 minutes, but it's almost 15 minutes the job has started.
Why this exists?
So there is always overshoot because the estimation in real time, they are not exactly 100% same to same. Because this was a calculation by the software and the firmware runs as a different clock. Maybe we can just pause the job and have a look. How it did. So there we can see that it has printed the fins, and there was support material on the bottom side, so that has it done fell, but unfortunately he broke one fin. So there you can see there is a lots of scrap material deposited over here. That was because unfortunately he broke that fin while printing. So the extra material which was coming out, that kept deposited on that corner, and that has spoiled that job. Yes, but here you can see that the fin are very thin enough. You can see that they are very thin, right? So you can see that here, this one. So these are very thin fins. So it will require a lower layer height thickness and a fine quality build style to print it in a more shapen format. So I can just remove this part so that we can take it in our hands and have a look and feel. So I just use this scalpel to remove it. So you can see it's very thin. The size of this one you can compare with this stick. Yeah. Okay. So it will be so delicate that if I try to bend it, it will break up. Okay. This one? This one? Yeah, that was because, see, while it moving, see, it is touching that platform, it is touching that object. So it was so thin, you see this fin, if I can move it, I'm touching it, it is moving. It is so thin. So when he was moving over the object, so the fin were moving, and that eventually broke down. Okay, and that is why the extra material which after breaking up, he was still depositing at that junction. See, अब वो ऑब्जेक्ट टूट गया है, बट वो स्टिल वहां पे डिपॉजिट करता जा रहा है. देखो, उसको ये नहीं पता चला ऑब्जेक्ट टूट गया है. There is no feedback that object is properly printing or not. So that the user has to take care. Any other questions, doubts you have? There are a couple of sites which I can share with you from where you can fetch some information on 3D printing technologies. Like there is a Fapster.com, 3ds.org. That's a very popular site from where you can get a lot of information. That what kind of printers are available, what kind of technologies are there, and what is happening in the 3D printing world.
Excuse me, sir.
Yes.
So it's from ABE's college. Sir, I want to ask the material, unwanted plastic there. How would we remove that to finish out the product?
You mean to say that the material?
The scrap material there.
Scrap material is a waste then. So,
How to remove it? He's asking.
how to remove it? Yes. Which one? This is at the bottom side.
The scrap which layered there, which we don't want.
Support material.
Okay, the support material, you can just use cutter or some filing material to remove it. I believe I would have some cutter with me. Yep. So you can use a simple cutter to remove this extra support material.
No, sir, no, not that one.
Okay. The bottom one, which one?
Same material which is formed also.
Which we are getting on the product.
This one. So you can just cut and remove it because
It will
ABS.
come in this case only. No, otherwise it would.
No, otherwise it will not.
Oh, fine.
And the bottom wrap you can remove just by peeling it off. It will just come out like peeling.
Would it not hamper to the other one, the finishing good product?
It will not help.
Hamper. That means.
No. It will not. You have to be careful that definitely when you are using the cutting tools, you are not damaging the part then.
Because our cutting tool is not very precise to just deal with that layered product.
Okay. No, you have to make sure that when you are cutting it in a proper method, and you are not damaging the printed part. But this was in a special case that this part was got faulty. Otherwise, no, you don't face such kind of problems. But yes, this technology itself is not 100% proof that every time you print you will be a success. There might be some failures, and you have to go with it. Now you can see that I have removed the support material. So it gives the same shape what we saw in the software. So I just removed that support material very easily. So it will not damage your part.
Hello sir, actually we wanted to know, is this the final product, or like does it go any kind of machining after completion of this?
No, generally in 80% of the cases you don't require machining. Sometimes some user require a better finish, so then they can do sanding or filing, they can do it. So that additionally should take few minutes, or let's say half an hour at the maximum, to complete the finishing of the product.
Okay sir, thank you so much.
Okay. Anyone from any other centers? Jaipur?
Yes, sir. Hello?
Yeah. Hello.
Yes, sir. Jaipur Engineering College Focus.
जी. Yes, you have any questions? Jaipur?
No, sir.
Okay, thank you.
Thank you, sir.
This thing is possible only with materials which can be melt.
Yes.
It's not for metal.
No, it's not for metal. But yeah, if you design an extruder which can, melt at the given of, let's say, aluminum, which is around 1000 degrees, then it's possible. But then that's not that easy. Otherwise, people would have done. Although there are some metal 3D printers are also available, but they use a powdered metal which is also they use electron beam melting. So instead of laser, the cure is using electron. Yes.
Hello, sir.
Yes, dear.
Sir, Agresin College. Sir, actually, I want to don't want to approach from bottom. पहले से अगर मटेरियल को फिक्स कर दिया जाए, पहले से सपोज सिलेंड्रिकल फॉर्मेट है, पहले से मैंने मटेरियल रख दिया, उसको कट कर दिया, ठीक है सर, 3D अप्रोच में
जी,
ऐसे कर सकते हैं इसको?
बिल्कुल कर सकते हैं, बट देयर आर ओनली फ्यू प्रिंटर्स अवेलेबल व्हिच कैन डू द जॉब, व्हिच इज आल्सो कॉल्ड एज सबट्रैक्टिव टेक्नोलॉजी.
सर एक्चुअली बॉटम अप्रोच से एरर आने की जो चांसेस अभी जैसे सपोज दैट अभी आया था, उससे टॉप अप्रोच में ये होगा, टॉप टू बॉटम अप्रोच में एरर कम आ सकता है.
नहीं, सबट्रैक्टिव टेक्नोलॉजी में ज्यादा प्रॉब्लम आती है.
ओके.
बिकॉज आपको सिलेंडर प्रिंट करता ठीक है, बट अगर आपको कुछ शेप ऐसा करना है जिसमें अंदर एक हॉलो बनाना है या अंदर एक कट बनाना है, सो दैट इज नॉट पॉसिबल यूजिंग एंड सबट्रैक्टिव टेक्नोलॉजी.
इसके थ्रू सिलेंड्रिकल फॉर्मेट में बीच में हॉलो हो सकता है,
बीच में हॉलो हो सकता है, बट बीच में अंदर की तरफ में स्लॉट्स बनाने हैं और बाहर से पूरा बंद रखना है, इट पॉसिबल.
ओके ओके, बट उसकी तो एफिशिएंसी भी ज्यादा हो सकती है, जल्दी अप्रोच भी अच्छा होगा उसका, लेकिन हाँ उसके लिए हम इसके लिए सोच सकते हैं अगर अंदर से हॉलो रखते हैं. थैंक यू सर, बस यही पूछ रहा था.
चलो, आइडिया अच्छा है, ट्राई कीजिएगा. थैंक यू. Anyone from here? Okay then. Thank you everyone.
Thank you, Mr. Vinay, for a very interesting and very informative talk. So actually I would like to add that the fault, or you can say the defect that occurred right now in the during the presentation, that is an aberration. Why? Because when you use these machines, they have to be installed at one place and very properly aligned. Right? So if there is some misalignment, or the surface is not properly, the surface is rested, that is not flat, misalignments can occur. Since this machine is being used for demonstration, so it is being carried, it is being packed, repacked. Yeah. So that is why this defect has occurred. Otherwise, defects do not occur.
No, moreover, it is because we have to be patient enough. Yes. Because as we saw that I used the worst quality to print, yeah, and still it was taking 15-20 minutes.
Time was,
yes, the time is short. Otherwise this we have printed many number of times this turbine model. That's what I'm saying, yeah,
right? So the apprehension that you have regarding that how to remove the, you can say, the waste material, actually that is once in the blue moon type of thing. Otherwise, one has to remove only the scrap, the support material, and there are other methods of removing support material, like for example the polymers that are used to print these models. The support material is different, so you can also put them in water, and many times the water or maybe a chemical in it will wash away the support material. So as such, there is no problem. So you must have gone through the news items that now people are building, people are making even guns using 3D printing technology, and it becomes a security concern because since it's a polymer material, so they are not being detected at many places. So, Mr. Vinay, I'm thankful to you. You came all the way from Pune and gave a live demonstration yesterday, and again a demonstration today. So I hope all the centers and the participants in the studio, they liked the information. They must have enjoyed it as well as learned the new concepts. So now for the remote centers and for the participants, we will have the valedictory session at 12:15 p.m. That is half an hour after this. So our director and the head of department of mechanical, they will be participating in the valedictory session. So now we'll break for tea, and I request all the centers to please be in their halls at precisely 12:15 p.m. And I will also ask the coordinators at the respective centers to kindly invite their directors or the heads of the departments to participate in the valedictory session. Thank you, one and all.
Thank you, everyone.
तो नहीं, आपको और क्या लगता है कि ये चीज और होना चाहिए? ओके, ठीक है। हाँ हितेश, ओके। हाँ, वो स्पेसिफिकली व्हेन वी डू कोर्स सच टाइप ऑफ कोर्सेज, अब ये क्योंकि हमें ये ऑनलाइन करना पड़ा इसलिए हो गया, रहा था कि लो ये कौन। हाँ हाँ, Sivanandani, oh, you have again come back for this course. Oh, you are the same Sivanandani. Okay, okay, okay. So, what you wanted to say about this course? No, that is good. Okay. Ambika Devi. Yeah.
So basically I'm from electrical background, so I find everything interesting only. But robotic programming it would have been interesting.
Okay. So, anything else you wanted to know from me? I'll be happy to answer your queries. In fact, I'm waiting for Dr. Punia. He was supposed to come here, and your coordinator, Dr. Dhani, has gone to bring him here. He has sent me a message that within 5 minutes he's coming. Okay, anything you wanted to ask me? Hmm?
ऐसी कोई शॉर्ट टर्म कोर्सेज और पॉसिबल है जो इंडस्ट्री में हो और अपन प्रैक्टिकली देख सकें, जिसमें फिर हम प्रैक्टिकली नॉलेज ज़्यादा
सी इसमें मैंने जैसे कहा ना, इसमें हमारा ये लिमिटेशन हो जाती है टू take you out to the industry because we are already connected to different locations.
कोई ऐसी कोई स्पेशल कोई शॉर्ट टर्म हो जो वहीं हो, यहाँ से कोई कंडक्ट अपने यहाँ से कंडक्ट हो,
हाँ,
इंडस्ट्री में हो।
अच्छा, you want every content to be covered in the industry. उसमें हमारी रिस्ट्रिक्शन ये होती है, इंडस्ट्री वाले 5 दिन के लिए लोकेशन निकालना उनके लिए डिफिकल्ट हो जाता है. वी नीड टू कोऑर्डिनेट. इनफैक्ट वी विल ट्राई इन फ्यूचर कि अगर हमारे साथ ऐसा हो सके. सो we'll see that in future if we can do at least we'll try 1 or 2 courses कि हमारे इंडस्ट्री में हो सके कोई. It's a good suggestion. Any other question before I hand over to Dr. Dhami? और कुछ पूछना चाहेंगे आप? ठीक है, we'll try. ठीक है. हाँ.
ये वाला बंद कर दो, प्रोजेक्टर हरजो. Okay. Good afternoon, participants in the studio, participants at 4 remote centers. So in the valedictory session of this course, we requested our director, Professor M.P. Punia, to grace the occasion. So he has readily agreed, though today there are a number of courses which are winding up and he had to attend other functions also. We have with us, apart from Dr. Punia, Dr. S.S. Banwag, Professor and Head, Mechanical Engineering Department, Dr. B.S. Pabla, Professor Mechanical Engineering and Professor and Head IMCO of this institute. So in this course, friends, as you know, we went through a 5-day program on industrial automation and robotics, in which we covered a variety of topics. So we had starting from digital logic, to programmable logic controllers, and then automation industry, microcontrollers, control systems, and rapid prototyping technology covered. So I'm sure that the course was fruitful to you. So now in the valedictory session, first of all, I would like to invite our remote centers one by one. So first of all, I invite the coordinator at Jaipur Engineering College, Jaipur, to please. हाँ जी प्लीज बोलिए. गुड मॉर्निंग जी, यू गिव योर फीडबैक प्लीज.
I am Blackma Meena, coordinator of Industrial Automation and Robotics from Jaipur Engineering College, sir. First of all, thank you, sir. Dr. S.S. Ramani and Dr. Tripathi and Dr. Devesh and Naga. And then expert advanced technology. We are RC. Thanks.
उस माइक की बजाय अगर उसी का लैपटॉप वाला ही माइक काम में लें. प्रोफेसर तुम उनको बताओ.
तुमको बताओ क्या
बताओ प्लीज कन्वे व्हाट प्रॉब्लम इज कमिंग. जस्ट यू कन्वे दैट लैपटॉप माइक दे शुड यूज इन प्लेस ऑफ दिस एक्सटर्नल माइक. नो
सर आप थोड़ा ना सिस्टम के पास आके बात कर लीजिए सर.
ऑडियो प्रॉब्लम
आ रहा है.
सर आपका माइक ऑन है सर, आप बात कर सकते हैं.
हेलो मेनली सर ऑडियो प्रॉब्लम.
हमें आपकी आवाज आ रही है, बोलिए आप.
Yes, sir, you can speak. We can hear you, sir.
नेक्स्ट सर.
Yes, sir, we can hear you. आप बात कीजिए सर.
आप बताएं प्रोग्राम कैसा लगा आपको. 5 दिन का ये प्रोग्राम कैसा लगा आप लोगों को. जस्ट यू कन्वे टू अस.
सर मेनली प्रॉब्लम सर ऑडियो प्रॉब्लम्स. दे आर जस्ट इन 2 or 3 days starting, and other video problems are
मिस्टर पुजारा हैं क्या वहां पे. प्रोफेसर पुजारा हैं क्या.
नो सर.
अच्छा, हाउ मेनी पार्टिसिपेंट्स आर देयर. हाउ मेनी पार्टिसिपेंट्स अटेंडेड दिस प्रोग्राम.
यस सर.
कितने लोगों ने अटेंड किया ये प्रोग्राम.
सर 25.
25 तो दिख नहीं रहे तुम लोग. तो 2-4 दिख रहे हो यार. और न तुम बता पा रहे हो कि आप लोगों को 5 दिन में ये प्रोग्राम, एक तो ऑडियो वीडियो क्वालिटी का हो सकता है आपको कोई दिक्कत आ रही हो, पर ये बाकी दिनों में कंटेंट्स आपको डिलीवर हुए वो कैसे लगे. आज जो प्रैक्टिकल पार्ट भी रैपिड प्रोटोटाइपिंग मशीन का हो रहा था वो समझ में आया क्या आप लोगों को.
यस सर. अच्छा लगा सर.
क्या चीज अच्छी लगी उसमें. मशीन अच्छी लगी या प्रोसेसेस उसके अच्छे लगे या बताने वाले अच्छे लगे.
ओनली प्रोसेसिंग एंड वीडियो क्वालिटी एंड अदर एडवांटेज एंड क्वालिटी.
ये कहाँ पे काम आती है आरपीटी जो है, किस जगह काम आती है. कोई प्रैक्टिकल कंपोनेंट बनते हुए जो कहीं देखा आपने, एग्जांपल दिखाया आज आपको उस वीडियो में कि कहाँ पे कंपोनेंट बनके कहाँ पे यूज आते हैं आरपीटी से.
आ रही है आवाज.
अच्छा चलो दूसरे सेंटर पे देखिए. अभी इनको कहो वापस आते हैं तो आपके सेंटर पे कि आप लोग जो फीडबैक देने वाले हैं वो तैयार हैं. अभी वापस आएंगे आप लोगों के पास. एटलीस्ट 2 members प्लीज कन्वे टू अस वट एवर यू लर्न इन 2 days. व्हाट आर योर सजेशंस. दैट एग्जैक्टली वी वांट. इसीलिए तो रखा था अपने वैलिडिटी फंक्शन. इसे हमें पता चले कि कितनी चीजें समझ में आई आप लोगों को इन 5 दिनों में. ठीक.
Okay, next I invite the coordinator at ABS Engineering College, Ghaziabad.
So, आपके वेरी गुड स्टूडेंट्स भी बैठे लग रहे हैं मेरे को इसमें जो वेरी
हेलो
गुड. हाँ
हेलो
हाँ बोलिए प्लीज, अब आपकी आवाज सुनाई दे रही है, बोलिए.
गुड आफ्टरनून सर. Really, this program was very productive for our participants. About 40 participants participated in this program all through 5 days. And there are overall 12 sessions. Every session was very productive and we have learned a lot. Now, in spite of in the beginning there was some sound quality problem was there, and then there was some transmission problem was there. Otherwise the program was very productive and very effective program. I would recommend that these programs should be held in future also, and our institute is regularly organizing these types of program. Earlier we had this program in our EC department also. So really I am thankful to Professor Dhami, whose contribution was marvelous, and other professors and prominent personalities also delivered their lectures very effectively. Thank you very much, sir.
And any suggestion about this program? Suppose in future we are conducting the same program, what should be the contents? In this program there were 5-6 experts were there. Majority of them were from academic side, one from industry. No, so yes.
JSP industry say.
Yeah, one section is there. This program is of 5 days and it is a very lengthy program. You can curtail it to 3 days program, because the 5-day program and the productive portion is about 40%. I think the overall 40% productiveness is there. So we can curtail the number of days and we can have this program for 3 days.
Out of this one, what can be curtailed? Say when industrial automation we are saying through robotics, what can be curtailed here? PLCs you have studied, then microcontroller.
Time utilization was very less,
okay.
So we can have the utilization of time.
Okay. Chalo, next one. Any other suggestion?
Thank you, sir. That's all.
Okay, best wishes.
Okay. Thank you so much. So now I invite the coordinator at Maharaja Agrasen Institute of Technology, Ghaziabad.
हेलो हेलो
हाँ जी बोलिए प्लीज.
हाँ, good afternoon everybody. Myself Dr. Piyush Dua from Maharaj Agrasen Institute of Technology, Ghaziabad. So from my institute, around 30 people have participated in this program. As the classes have already started, so most of the faculty members, they used to go and come back after taking their classes. So, but I took feedback. Most of the people are very satisfied with the quality of the contents as well as the delivery of the speakers, and they were requesting me to have such programs on a regular basis. And if a series of programs can be developed, that would be very helpful. For monthly, if we can develop some program, and that will be very helpful for the development of the faculty members, and that can be communicated to the students in the regular classes. That will help the students as well.
Okay.
Okay. Thank you, Professor Dua.
Thank you.
Now we go to RD Engineering College, Ghaziabad.
पुलिस वाले तो आते थे आगे का
हेलो
हाँ बोलिए प्लीज.
Good afternoon, sir. Myself Mohit Kumar Singh, Center Coordinator of RD Engineering College, and I thank you very much for giving us the opportunity of organizing the STC on our industrial robotics, and it was very beneficial for all the participants. All the participants attended it for the 5 days, and they enjoy the content delivery by the expert from your institute and from the industry also. And I have one request that to the course coordinator that they share with us the PPT that the expert uses for the presentation, so that we can distribute among the participants. And from our center, one participant, Mr. Paritosh Gautam, want to give the feedback also.
जस्ट वन क्वेश्चन फ्रॉम माय साइड कोऑर्डिनेटर साहब, आपने कितने सेशंस अटेंड किए थे आउट ऑफ दिस? आपने कितने सेशंस अटेंड किए इसमें से?
आउट
ऑफ दिस 14 सेशंस, नो, हाउ मेनी यू हैव अटेंडेड?
Out of 14 sessions, we attended around 10 sessions, and we could not attend all the sessions because the classes are in full swing, and we have to attend. We have to take the lecture also for that.
Okay.
Sir, Mr. Paritosh want to give the feedback also.
Sure, हाँ जी, आप दीजिए feedback.
A very good noon, sir. And I just wanted to say that all that you gave up, all the material used in the training was really an impressive one, as well as the videos that illustrated the technology, and all the description that was given related to the figures used. It was very much prominent, and the video quality was better as compared to the last time. And anything ahead to this is very much acceptable from in the future. But this was the optimum quality of the train that was intended to be given, and that could have been there given to the other teachers through Google Hangout. And so it was really impressive, and I'm totally satisfied by the efforts of the teachers as well as the trainers. So it was all a very great experience working with you all.
Okay, thank you, sir. Thank you.
Thank you.
Right. So now I will request Jaipur दोबारा
देखो हाँ
so we would like to go back to Jaipur Engineering College once again, because so that they can give their feedback. Dr. D.N. Naresh at Jaipur Engineering College, Jaipur. Dr. Naresh is there.
Hello. हेलो,
हाँ जी बोलिए, आवाज आ रही है आपकी. Welcome, sir. Please give your feedback. Good afternoon.
The workshop was fantastic and well organized, and the students of JCKIT and other faculty members of different institutions have been here, and they enjoyed the PLC course as well as the microcontroller and the application. So the two things with the faculty members as well as the student feedback shows that whatever the lectures have been provided from NITR, we are very good, and I thank sir for giving the opportunity for us to be a part of a program for NITR. From our side, it was a fantastic one. Only the problem we faced to the initial time is that the login was not able to get it proper way.
the point which I wanted to tell you. And also, I'm very thankful for the senior sir for giving us this opportunity for us to our faculty as well as the students that to got the effective utilization of this workshop. Thank you very much.
Okay, sir. Thank you. So we have 11 participants in this studio. 4 are from Punjab, 3 from Himachal, 1 from Haryana, 1 from Rajasthan, and 2 from Andhra Pradesh. So I would like to know their feedback. So
सर एक प्रॉब्लम इसमें
इधर आके जैसे बाकी लोगों को भी सुने ना, या प्लीज डू कम हियर दिस साइड, इधर आपकी बात सुनाई दे सब लोगों को, है ना?
इंट्रोड्यूस हिमसेल्फ
हाँ, आप इंट्रोड्यूस करो।
पवन कुमार फ्रॉम गवर्नमेंट पॉलिटेक्निक कॉलेज बठिंडा from production engineering. I'm teaching production engineering.
Okay.
Here the course was combined. Basically, it was for more or less for electronics people.
Okay.
So my suggestion is that we should separate for mechanical and electronic people because simulation and all we don't teach to our students.
इलेक्ट्रॉनिक्स के कितने लोग हैं आप लोग इनमें से? जस्ट रेज योर हैंड्स. ओनली वन. बाकी तो मैकेनिकल के थे सब लोग हैं, इलेक्ट्रिकल के हैं. आप लोगों के रिलेवेंस का था ये जो है पीएलसी, और तो आप लोगों के काम किए हैं, माइक्रो कंट्रोलर आपके काम किए हैं.
मैकेनिकल वी डोंट नीड.
ओके.
सिमुलेशन एंड डिटेल्ड वी डोंट नीड.
ओके. ओके.
Little bit okay, it's done, but if
it should
we
be
can separate
separated.
these two courses.
Very good
mechanical
suggestion.
and electronic people.
Okay. Okay.
That will be great.
Okay. Okay. हाँ, ठीक है.
Anybody else?
So respected professors and my dear friends, very good afternoon to all of you. I take this opportunity, I'm actually Ambika Verma from SDM Government Polytechnic, lecturing in electrical engineering, Andhra Pradesh, Hyderabad. First of all, I take the opportunity of thanking our Commissioner SBTT and our principal for sponsoring me to this short-term course on industrial robotics and automation, industrial automation and robotics through ICT. And I thank the director sir at NITTR for providing us good facilities at this institution, and the head of mechanical department Dr. Benwell sir, and the course coordinator Dr. Dami sir for actually for giving us a well planned and scheduled period of time. The course was conducted, and we had we were provided with good, rich, knowledgeable resources. And it was really a privilege and pleasure listening to the professors giving us, precious talks, and I thank one and all for giving me this opportunity, sir. It was very good. But then I think a suggestible one is that this program could have been expanded for another week, sir.
Okay. Because, and suggestion was from other side. Suggestion was it should be only for 3 days.
Because like I'm from basically electrical background. I felt this was really interesting and informative.
Very good.
And this will be helpful to educate our students also, sir.
Okay. How was the stay here?
It was very comfortable, sir. But I think food was little like we are from the other side, so it was a little bit good. It was good, but not very good.
Okay.
Thank you, sir, for giving this opportunity.
Sir, during the stay, but I'm not staying here. But last time when I stayed there, it was in winter. When I asked another blanket, they said they charge me extra for the extra
blanket के लिए है. चलो we'll take it.
I'm staying with my in-laws.
इसी वजह से नहीं रुक रहे हैं कि ब्लैंकेट का अलग चार्ज कर रहे हैं या वैसे ही?
My in-laws are there in Chandigarh. Fortunately.
Okay. Any other participant would like to comment?
Now I'll request Professor S.S. Banwat, who is head of mechanical department, to please say a few words.
In fact, when you are not there, I was taking the feedback, and in fact, they have all appreciated this course and appreciated the effort of Dr. Dhami, and the various speakers who were taking the different sessions. And the suggestions which were the two basic suggestions which I got was that robotics part, the practical robotics part. Earlier we used to bring our robot arm here and do that practical here. So this time we were having some technical problem with the robot. That's why we haven't brought it here and we haven't shown that. So next time definitely we'll be bringing that and doing that programming and showing you all that. The other suggestion came to from one of them is that this course should be conducted in an industry. That is, all 5 days, all should have been conducted there, so that it would have been more beneficial to them. So we had some constraint, of course, so we'll try in future so that some such type of program we can have it in industry and can relay that to different locations also. So I'm thankful to the actor that he has spared his valuable time and come for this valedictory section. I also thank my colleague Dr. Pabla. Thank you.
Right, thank you, sir. So I invite Dr. Pabla to say a few words.
Thank you, Vice Dami. I already interacted with the participants because I had a session with them.
Yes, sir.
I'm happy that you are all happy with the content and the delivery both, because we are interested in imparting knowledge and as well as in giving some exemplary presentation to you so that you can copy and you see that, okay, how we present, so that you can also present your material in your polytechnics with the same grace and with the same details, with adding some ICT based tools. So we conduct a lot of programs and with your inputs we'll keep improving and adding more and more programs, so please keep connected. Thank you.
Thank you, sir. Now in the end, I will request our director, Professor MP Vinay.
Mr. Vinay?
Mr. Vinay. Vinay साहब बताओ आपका क्या experience रहा यहाँ पे?
Well, first of all, I was delighted to have such an audience remotely connected. The experience was good.
First experience, it was like this one, or earlier you had this type of lectures?
I had, but not in the live format.
Okay.
Yes.
That was recording somewhere, no?
Yes.
You were delivering, it was being recorded in that fashion you had done. Okay.
Yes. But definitely such kind of sessions are always, motivating for the participants, because they at least get to interact with people coming from industry or maybe educational background. So from my point of view, it is not always important to learn the technical aspect, but also how to deliver a subject.
That's true. That's very true.
That is always important. How to, create an illusion with the audience, how to make an interactive session with the subject, and moreover, importantly, like how to practically implement that ideas or the theory aspects into the practical world. So that's why I brought some hardware peripherals with me. So that is one dynamic modeling torsion bar, and along with the 3D printer, so that the people can see in the live how that works. So in that way, I believe everyone was benefited on that part, and I'm glad that I had an opportunity to interact with so many number of people. So I believe everyone enjoyed that part. So thank you, everyone.
Thank you, Mr. Vinay. Now I request sir to please.
So, good afternoon, and I'll congratulate you all the participants first of all at NITR Chandigarh studio as well as at the extension centers. Same time, I'll be extending my sincere thanks to our team members, dedicated team members, starting from head of the Department of Mechanical Engineering, Professor Benwet, Professor Pabla Saab, Professor Dhami. It's a serious efforts, in fact, wonderful effort, and Mechanical Engineering Department is conducting this type of program. We have started from internal combustion engine, one program we have conducted for 5 days, then another program we have done on robotics we have done, and that time in the studio itself we brought the robot here. And when we are conducting these programs, we are keeping in mind one is fundamental parts of that one, say industrial automation we are saying, then fundamentals has to be clear. In fundamentally we people are quite strong because we are handling these activities since a long time. Then another part is what R&D is being done in higher level of learning institutes, just like IITs, and those people are doing. So in these type of program, we are inviting those IIT professors also, that what research is being done in this particular area. And third one, industry part, how they are implementing that research which is being done. So we are trying to integrate at one common platform, that fundamental part, then R&D part, then application part. So in the same fashion, last program we have conducted internal combustion engine, in same fashion we have conducted here also industry expert who are really the manufacturer, who are really the contributor. They are in front of you, machine is in front of you. Even I can say with confidence in 99% polytechnics, even in engineering colleges, these RPT type machines are not available. In fact, also this itself is exposure. There is no question of your electrical, mechanical, civil, nothing is there. Some rapid prototyping procedure is being in front of you, it is being demonstrated. So it's exposure in fact, and as Vinay was saying, it is not only understanding this technology part, how the contents are getting delivered to the students. That itself is very, very important for us. And through this program, at least 5-6 prominent persons of this country, you are connected with them. No, important part is now you have to have networking, you have to have bonding with that one, and whatever you have learned here, it should be delivered to the students. That's the foremost task, in fact, of this type of program. Learning is not important. Important is how it is getting delivered, how it is being received by students. So when you will be leaving this institute, go seriously with lot of energy, lot of enthusiasm, with lot of value addition, and please deliver to the students. Students are having lot of expectations, and particularly in these areas. Suppose if I am saying mechanical engineering, mainly the specializations which we are having, one is industrial engineering, another one is thermal engineering, another one is design engineering. In those three areas, even laboratory facilities, everywhere reasonable facilities are available. But as far as this manufacturing part is concerned, as far as automation is concerned, as far as robotics is concerned, this area is very, very costly. So it's very difficult to have these type of facility in every institute. So in this wonderful institute, and if facilities were not there, we are called here. We have captured the facilities here itself. Experts wherever it were possible, we have invited here. So I think it was a combination of this practical part as a theory part, and my suggestion is the relationship which has been created here, the networking which has been framed here, please maintain that one. Please be in touch with these prominent professors for your development, and in time to come, the suggestions which you people are giving, according to that, again and again we'll be conducting these type of programs. Our target was just to initiate a spark in your mind. Everything can't be delivered in 5 days. Even it may 15 days, it can't be delivered. We are of the age of 30 years or 28 years, 32 years. Even the things which are learned in 32 years, it can't be explained in 5 days. So, but the spark which has been initiated, the references, the contents which are available, PPTs which will be available with us, please try to utilize with them with up to the maximum possible extent. Students are having lot of hopes from us. Parents are spending lot of money for the purpose of education. In India, education is very, very costly, very costly. 40 crore people of this country are earning less than $1, and they are sending their children to us with lot of faith that in 4 years they'll be the reasonable person who will be best fitted in the society. But what majority of the industries are saying, that only 20% students are competent enough to get job. So where then 80% will be going. Their parents had spent lot of money, and after 4 years, when question of serving to the nation is coming, the industry people, the stakeholders are refusing that they are not of our use. It means from our side, some shortcomings are there. Some serious efforts which has to be, these are not being put. So please try to do those serious efforts. The purpose of this institute not only to impart this content based training, your mindset also has to be changed. The work culture of this institute, as madam was saying, everything was good, food was not of that level. Food is not important. Important is with how much zeal, enthusiasm, how much we can contribute. Food तो 5 दिन में कोई फर्क भी नहीं पड़ता, और 1 महीना भी आदमी को खाना नहीं मिलता, it won't matter. It matters कितना आप जो है कंट्रीब्यूट कर पाएंगे इस चीज को लेके. हम साउथ में आपके पास आएंगे, विल आस्क फॉर दिस नॉर्थ इंडियन फूड जो है ना, हम वहाँ पे सब्जियां मांगेंगे आपसे, यहाँ वाली भी जो है, इट विल वेरी डिफिकल्ट. सो इट्स ए ह्यूज कंट्री, ह्यूज नेशन, thousands of different cultures are there, lakhs of food items are there, very difficult to arrange in that fashion, but it was good. Okay, so best wishes, and in time to come, my suggestion is please be in touch with our people, and at least this activity which we have started now, majority of the programs which are conducting, we are conducting through ICT mode. Our operation plan is available on our website. Please be in touch with us. Even we can connect from Andhra. Many of the teachers, they have come here under TechU program also, and in your institute also we can connect from here itself. Just one time you came here, you have seen everything. Now next program according to plan, you please send to request to us. We'll be connecting there itself, and so even your efficiency, productivity will be increased. 9:30 we are starting our program. Before that one, you can contribute in your institute. After 4:30 you can contribute in your institute. This travel, everything will go. So be in touch. Be connected with this one. Again, Professor Dhami साहब, thank you. Thank you. One lecture I attended, and मेरे को लगता है आप जितना मैं सीख गया था उसके अंदर जो है, the way you are delivering. Thank you. Yes, wonderfully you are delivering, and please keep it up. Pavla साहब, बहुत बहुत बधाई आप लोगों को, बेस्ट विशेष एंड होल ईटीवी डिपार्टमेंट टीम since last 5 days. Yes, sir. Day and night they are working. Very serious effort these people are doing. At least try to copy their efforts also. इसी तरह के एफर्ट्स वहाँ पे जाके करने इंस्टीट्यूट में. ये तनख्वाह उनका कि वहाँ ज्यादा बात नहीं करना कि मेरे 7वां पे कमीशन 6ठा पे कमीशन. इट इज नॉट इम्पोर्टेंट. Important is how seriously we are contributing for the development of the nation. That's important. ये देखो एमटेक के स्टूडेंट्स हैं, काफी बार ये नीचे बैठ के भी सारी चीजें कंट्रोल करते हैं जमीन पे भी. This has to be copied. So thank you very much. Best
Thank
wishes.
you, sir.
Please
So
keep
thank
it
you
up.
for very motivating words.
Okay. Okay. ठीक है.
So please be in touch. Sure, sir. I'll meet you.
Okay. Please. I'll be waiting. और इन लोगों की और क्या क्या हो सकते हैं, अपने कैसे टाई अप्स हो सकते हैं, जस्ट यू प्लीज